So this one here, we're trying to find the x and y coordinate. What we've been given is one length and an angle. Since we've only been given one length of a right triangle, we cannot use Pythagoras to find the other sides. So we're going to have to rely on the angle to generate some ratios. And again, that implies that we need to use a calculator. We're no longer dealing with exact values. Okay, so I'm going to do this. I'm going to say that the sine ratio of 67 degrees, that's equal to the opposite side, y, or vertical. Okay, remember that we want to connect sine with vertical, cosine with horizontal. So there's my y, and it's being compared to my hypotenuse or my radius, which is 8. So I can work out the sine 67 degrees from my calculator. Okay, so I go sine 67 degrees gives me a ratio of 0.921. That's equal to y over 8. Okay, so y over 8, I need to solve for y. Okay, I just cross multiply this. This length here, y, then works out to be 0.921 times 8. Okay, I get 7.36. Okay, so that length is 7.36. Okay, so at this point, I have two sides of the right triangle. I can use Pythagoras to find the third side. Okay, so this third side here is x. Okay, or I can use the cosine ratio, which goes with x. So I'm going to do it both ways. So I'm going to show that cosine 67 degrees, that ratio, whatever I get from that, when I type it into my calculator, is going to be equal to x over the radius, which is 8. So at this point, I need my calculator. I need to generate from the angle description, I need to generate the ratio description of this shape. Okay, 67. I get 0.391. That's equal to x over 8. And I can solve for x, and I get x is equal to 3.1. I'm going to round that to 3.13. Okay, so I can find those x and y coordinates. So now I can write my x and y coordinate. My x coordinate is 3.13. The y coordinate is 7.36. Okay, so those are my x and y coordinates. Now the other option is I could have used Pythagoras to find that third length. Okay, and it would have looked like this. Okay, so this is an alternative solution. I could say that x squared plus 7.36 squared is equal to 8 squared. Okay, and then solve for x. So plugging this all in, 8 squared minus 7.36 squared. Okay, solving for x. Okay, using my calculator, I get 8 squared minus 7.36 squared, square root that number. I get 3.14. Okay, when I round it, I get about 3.14. It's 3.135. So given the difference here is just going to be the rounding error, this is essentially the same solution. Okay, so I'm just going to leave that as 3.13, but notice that these solutions are just alternative ways to get the same thing. where the error is just going to be from rounding. And either way is perfectly fine. I will account for these types of problems. I will account for your rounding errors. And as long as you're within, within reason, these are perfectly fine solutions. And one is using trig to get the x value here. The other is using Pythagoras, and they are equally valid methods of solving for that last side.